Hello and welcome everyone to the part 3 of this series of videos where we are building a real-time AI chat application. And in the previous videos, we've discussed how the app's front end and back end communication was working, right? So in that case, we've seen how we have used HTML, CSS, JavaScript to build a front end UI, and then how a fast API app is being built on the backend side and how they both are communicating with each other. So if you want to do a summary over here, there are slash WS, so WebSocket based communication at that endpoint, and slash session, and that was a get call for the slash session. And then there is another, whoops, no, come back please, deleting just the space. Okay. And then there was a slash chat endpoint, right? So there is a WebSocket communication, there's a slash session, and then actually let me put in an order too. And then there is a slash chat endpoint. And these three endpoints, they are available in this particular AI server that we are calling, right? So let me make a big box over here. Let me put all this, we'll send it to back and send backwards. Oops, all of it needs to go back. Send to back. Okay, perfect. So all this is part of, let's do this. Okay, so this is part of our backend communication that this AI server is providing, right? And let's call this AI server as our fast API um, backend server, right? A little bit more fancier than just a AI server. So this is our fast API backend server, and these three endpoints we are interacting with. Now, where is the AI coming into picture over here, right? So the AI comes into picture. Let me delete all this over here for now. So the AI comes into picture where this fast API server utilizes some logic within these endpoints, right? So the AI logic that is being involved is in this slash chat endpoint. The other two endpoints are pretty straightforward and simple, and please watch the previous video to understand what they are. But initiating the session and having the WebSocket based communication does not involve any AI intelligence. It's only this slash chat endpoint that does. So how do we get the AI and intelligence in this slash chat endpoint? The way we do this is we delegate the work from here to a different endpoint, REST-based endpoint, right? So exactly in the same way how the web browser is doing a request and a response from this fast API backend server, right? The Python fast API backend server. In the same way, this backend server can in turn do request and response with a separate server, right? What that separate server would be, it could either be an OpenAI server or it could be an Ollama server, right? So in our case, we are going to use Ollama server and not the OpenAI server, even though you can interchangeably use whichever one you want with this application, because Ollama supports OpenAI's request response format. So you can just switch Ollama with OpenAI if you want. But while we are developing it in the local environment, I'm going to choose Ollama server, which is where I will show you a couple other modifications that I have done to the code base to make it easier for you to understand where these Ollama and OpenAI related backend server configurations are residing. All right. So what happens when you invoke a slash chat endpoint? So let's go to the UI over here. I'll initiate hello, my name is Mukul, right? So slash chat endpoint got initiated and it says sending request to AI model, right? So we are at a point where we are attempting to do a request response to a backend server, and then from there to another backend server, right? So we already sent a slash chat request from browser to this slash chat request. But now this API backend server is sending a request to Ollama server, right? So this is what is happening at this point of time. It is sending a request to the Ollama server and it is still waiting for the response back. And now it got the response back, right? So there was something, there was a wait, there was a little time that was being spent that you waited for. And while you were waiting, a processing was happening. So I wanted to show you exactly how this was happening. From the UI, you send a request to slash chat endpoint and to the FastAPI backend server in the slash chat endpoint. And the slash chat endpoint then in turn sent a request to your Ollama server. And then Ollama server received that request and then proceeded to return the response back to the FastAPI backend server into the slash chat endpoint, and then that endpoint in turn then return the response back to you. So one thing that I want to show you is that whenever Ollama is returning the response back to the slash chat endpoint, we may not be returning the response straight away to the user, right? We may do some massaging, some formatting, extracting some data out. We are not sending the exact same response back to the user. Why? Because the data that Ollama server or the AI server will send back, it may have a lot of noise in it, right? So whenever you send a request, a response, a request to your OpenAI or Ollama server, it receives the request and it sends the response back in a way which is more developer friendly. So whenever you send a request, it also sends back in the response not only the actual content, but some metadata around it, like how long did it take to process the request? Do you need any tool call to process subsequent requests and all that? And that is why we cannot just simply send the data that we are getting from Ollama server to our front end user right away. We need to do some kind of data massaging, manipulating, and looking at if Ollama server is requesting us to do certain more actions before you can send the response back to the user. And this is where agentic flows come into picture, right? So this is where I want to explain a couple more details on how requests and responses are done with any AI-based server. So I'm going to pause over here. Whenever we do a request response with a REST API endpoint, those request responses are stateless, right? I mean, you can build in a session concept over there, and then you can make a session attribute stored on the server side, and then you can pass that session attribute to the server side with every request, and you can maintain a session, and that's all right. But every request in itself is stateless. So in every request, we are passing the session attribute from the browser to the web server. And the web server is then processing based on the session attribute the data and then returning the response back. But in reality, every request is stateless. Every single request going from browser to the backend server in the REST API call is stateless. It is unaware of the previous request that was sent. You are making a logical correlation between the requests by passing the session attribute. But in reality, the request itself is stateless. And it's a very important concept to remember that two requests that are sent to a RESTful API backend server, they are stateless. They are unaware of the previous requests. We as developers, we logically create association by sending a session ID, but it doesn't mean that those two requests are stateful. They are still stateless. Similar to that, any request that is being sent to an Ollama server is stateless too. right? So there is no way these requests are being maintained in terms of states to the previous request. So whenever I send a question like this and I ask, what is my name? If the server responds back that my name is Mukul, it feels like this whole interaction that is happening is stateful, right? So it feels like somehow the server not only knew what my name was, but it also sent me the meaning of my name, right? So let me see this. Let me ask again, what did you say the meaning of my name was in your last message, right? So when I ask it this question, and if it comes back with blossoming as an answer, right? It said that I said that the meaning of your name, Mukul, was blossoming. How is it doing this? On the one hand, I'm saying that all the requests that are going from the chat API endpoint to Ollama server are stateless. And yet, the AI server, when it was returning the response back, it knew that it had said blossoming in its last response. How is it doing that? This is where the concept of chat completions endpoint comes into picture. So in our slash chat endpoint from the fast API backend server endpoint, the one that our web page is calling, in that endpoint, we are building up a, a whole chat model that we are sending to Ollama server. And we are utilizing a very special endpoint called chat completions endpoint. And that endpoint, let me show you over here. OpenAI API chat, well, documentation. Right? Let's just open the documentation API reference. Oh, chat completions endpoint right there. So if you see this chat completions endpoint, you'll see that they have provided us a way to send the request, right? So like I said, every request is a JSON formatted REST API call, essentially, right? So in this call, what we are saying that, hey, the model is this particular model we want to use. Messages, these are all the previous messages that you have sent, right? So at the very top, there is a system message, and there is only one system message per conversation. It defines what the whole conversation is going to be like, right? So you can tell in the system message the behavior of the large language model. You can tell it that it is a helpful assistant, and it is smart at keeping a conversation going, or it is very witty or funny or whatever, right? So you can define your system attribute for the LLM, which guides the rest of the conversation. And then you can have a role user, which is an actual user's message that is going out, and the content of that message, right? So system is only one, then you can have a user message go over here. And then as a response, you will get a assistant message come back, right? So once you send this particular kind of request to the large language model, then this is the response that you get back. You get the response, role assistant, and content, something in there, right? And then as a developer, it is your responsibility to append this role and content as the next set of role and content when you are sending it back to the large language model, right? So what do I mean by that? So let me just send a empty or create an empty session over here, and let me send a hi, right? So the very first request that I sent, in this request, it just had a system message at the top. It had a user message of hi, and the response that we got was this particular assistant message. Now, as a developer, it will be my responsibility to build a system, same system message, same hi, and this new assistant message, and a new message that I'm going to add on top of it, right? So My name is Mukul. So now this particular message I'm adding on top of all the previous conversation in my JSON request, and then I'm sending it to the large language model. So now that we have talked about this chat completions endpoint and how we build that, let's just take a quick look at how this is actually being built. So if you have a Ollama or OpenAI server, right? So this particular thing is, one second. This is your Ollama server over here, and you have chat completions endpoint available in Ollama server, right? So let's just take that, uh, and let's just paste that over here. So this is your chat completions endpoint. And in this chat completions endpoint, you are formatting your messages. And how are you formatting it? You're formatting it in this particular structure. So what is this structure over here? Let's paste this over here and talk about it. So in this structure, you have a system message on the top. Then you have a user message after this, right? So system message that you cannot see because there's no point to show it to you. It is embedded on the top. And then you have a user message coming over here, right here. And then you have an assistant message coming back over here. And if there was a tool call, and I'll talk about tool call in a second, but if there was a tool call involved, then there will be a tool call that will be done, and a tool call message will be appended over here. You do not see tool call messages, but a tool call is also appended to the list of messages that we have. And then that tool message is sent back to LLM, and LLM gets an assistant response. And then that assistant response is being shown to the user. So there are some magical things that are happening, which is where I said that this chat completions, no, not the chat completions, but the chat endpoint on your fast API backend server does those things, right? So after the assistant has received its message, and if there are some tool calls, and if there are some extra processing that needs to be done, then all that happens in this slash chat endpoint. So this is a very important concept to understand, that you have your endpoint from the web page calling, you have your front end from the web page calling an endpoint on the fast API backend server. This fast API backend server in turn is calling a chat completions endpoint on the Ollama server. Now, chat completions endpoint sends a lot of details. It may send a very nicely formatted message, or it may send a tool request. And a tool request will be processed by not Ollama server, but by your slash chat endpoint, right? So there is a Python code in here which will receive the tool request. It will process it. It will send the request back to the Ollama server to get the assistant response. And then it will send it back to Fast API backend server, which is what will send the response back to the end user. Let's see this working in real time over here. So I will ask, what is the weather in Woodbury, Minnesota? And hopefully my environment is set up correctly. So it will have the environment key for that. So it is sending C processing tool calls. So now it's send and then sending request to AI model again. And then it is getting the information back. So there are three steps that happened over here, right? Let me do that again. What is the weather in New Delhi? Right? Let's do this. And you will see three interactions happen over here, right? So interaction one, sending request to AI model. Interaction two, processing tool request. And interaction three, sending request to AI model, right? So processing tools was so fast that you didn't really see it. But if I give it a more complex question, right? Which city is warmer? Phoenix or Delhi? I want to plan a visit to a cooler place. Right? Let's send this request. So sending request to AI model, right? That is the first one. and then processing tool call, second one, and then sending request to AI model again, third one. So 3 steps happen whenever there is a tool call. And it went in, it retrieved data for New Delhi, it retrieved data from Phoenix, and then it compared the two data, right? So the very first step that happened, so very first assistant call, so user send a request that, hey, which city is warmer, Phoenix, Arizona, or New Delhi, right? So that is what user sent the request as. Now assistant then realized that, hey, for this to happen, I need to do a tool call. I need to see what are available tools because assistant does not know. A large language model, an Ollama server in itself does not know what the weather conditions are. So what it says is, hey, are there any tools available to me? If there are any tools available to me that can help me retrieve this information, then I can ask the slash chat endpoint to run those tools and to give me the answer of those tools back so I can answer the user's question. So when we send this question to our Ollama server determined that, hey, if you give me the weather data from New Delhi by running a tool, and if you give me a weather data for Phoenix, Arizona for running another tool, then I'll be able to compare those two details and I can give you a logical answer on which place to visit, right? So it gave the tool request to the slash chat endpoint back, and slash chat then processed the tool request, right? It knew the way to run the tool because initially, while it was sending the request to chat completions endpoint, initially it had formulated the request in that way. And I know it all may sound complex right now, but once I show you an actual request response coming out of your slash chat to Ollama server, once I show you that, all these things will make sense and it will all fall into place together. So the very first point, once the assistant told the slash chat to run the tool, slash chat endpoint knew how to run the tool because slash chat endpoint is the one who had provided the tools to the assistant. So it ran the tool, it got the data back, and it sent that data back to the assistant. And then assistant responded back logically with this answer, right? So it says, however, please note that these temperatures are subject to change and might not reflect the exact conditions during your planned visit, right? So it is telling, let's ask it again. Um, if I want to visit Disney, which one should I go to? And you already know my preferences, right? So let's send this. It says send a request to AI model and processing tool calls. So it looks like it is processing a lot of tool calls right now because it's taking a lot of time, and then sending request back to AI model. And now it will get the final response back. It is constructing its final response. It's taking a lot of time, which means the final number of tokens are a lot. And there is the response, right? So it's saying it wasn't able to find direct comparison of all Disney parks. However, I can tell you there are 6 main Disney theme parks, right? So it got all 6 theme parks. And I think it has done, and I can look at the backend, what all tool calls it has done. So if I look at the bottom, it has done a tool call for New Delhi. Oh, so it tried to look at Wikipedia for the results. Okay, so let's see. Compare uh, weather information for all these theme parks and then tell me the answer, right? So let's send that request to it. And now it is the initial assistant, the first step that's happening. And it must have run some tools over here, hopefully. Get weather, Anaheim, California. Okay. So it ran one tool at least. and it is trying to get an answer back based on that. So it determined it needs to run only one tool, and it kind of messed up a little bit. Um, your answer was so garbled up. And we can continue the conversation over here. It looks like something failed in our request and responses, and it is not able to recover from there. It is trying to clear and concise writing style from Wikipedia. It is kind of messing up a little bit over here. And I'm just going to let it finish sending this request. And there you go. Okay. So it is trying. I think it is hallucinating right now. I don't think it has retrieved actual responses back. Let's see. So it got the response back for Phoenix, New Delhi, and Disney tried to go to Wikipedia, and it got the answer for Anaheim, but it did not do anything else. Okay, so I'll show you in when it actually does tool calls how it works. But at a higher level, I want to show you that uh, our front end is making interaction with our FastAPI backend, which is in turn making an interaction with V1 chat completions endpoint in Ollama. And the way it is doing this interaction is by building this particular messages object. And this building of messages object is being done in this slash chat endpoint over here. So the slash chat endpoint based on the session of this particular user, right? So you remember we are sending a message and we are sending a session ID. So based on the session of that particular user, this slash chat endpoint is building this kind of message structure, and it is passing this message structure back to the endpoint whenever the request is being made subsequently for that particular session ID. And this is one of the important theoretical concept that I wanted to talk about before we proceed into looking at the code, right? So very important concept that the web page isn't directly talking to Ollama server. It is being intercepted in between by FastAPI backend server. That FastAPI backend server's slash chat endpoint is talking to Ollama server, which is responding back, which appears to be a stateful response, but it is responding back in a kind of stateful way because we are actually passing the whole conversation in a very structured way in the role system, role user, role assistant, and role tool call, right? We are sending all that structured response to the Ollama server using the slash chat endpoint, and that is why it feels like these are stateful calls, even though in reality these are all stateless calls. All right, so this is all that I wanted to cover in this video: theoretical, conceptual portions of how our infrastructure and how our calls are laid out. And in the next video, I'll show you exactly how this code is written. And in order for me to show you that, I'll actually show you a very basic, simple example of building such messages and doing tool calls in large language models. So I'll showcase that, and then I will showcase how we are doing building of actual large language model response in the request using system user assistant and tools. Before doing that, I will showcase to you a simple example using a standalone application. All right, thank you everyone for watching this video. And as usual, there were two other videos in this series. Please watch that. And the code for this is in our GitHub repository. So let me see if I can quick show you that too. So in GitHub, I have updated this, and there are newer instructions over here where you can see install Ollama, right? So you have to install Ollama, and then there is a API URL over here. This is my Ollama server URL. But for if you have installed in your local, it most likely will be this, right? So please watch out for this port number 2. Your port number by default is 11434. I have 11436, and there is a reason for it. And there's a different YouTube video that I have made why I have 11436, a story for some other day. But I'll link that video also in the video description. I have multiple Ollama servers that are behind uh, a load balancer, so behind an Nginx server, and that is why I need to use different ports for my purpose. You will probably just need this particular host name and port name. All right. Thank you guys again for watching, and I'll see you guys in the next video.